Sketch the rational function y equals x squared plus x minus 12 over x cubed minus x squared minus 2x. Okay, so we can factorize the top, and indeed we had that in the last example. So we know that's x plus 4, and x minus 3. On the bottom we've got a common factor of x, which we can take out, and then we'll have x squared minus x minus 2, and so we've got x plus 4, x minus 3 over x and x squared minus x minus 2 would be x minus 2 and x plus 1. Okay, so from the bottom we can see that we've got vertical asymptotes at x equals 0, the y-axis, x equals 2, and x equals negative 1. We are going to have x-intercepts at x equals negative 4 and x equals 3, which we get from the numerator. Those are the values that will make y equal to 0, so we have to have the numerator equal to 0. And now we can investigate where the graph needs to be. So x plus 4 changes sign at negative 4. X plus 1 changes sign at negative 1. X changes sign at 0. X minus 2 changes sign at 2. And x minus 3 changes sign at 3. Okay, so if we're to the left of negative 4, all of those would be negative, and so it's going to be negative because there's 5 things that are negative. So basically we've got negative times a negative over a negative times a negative times a negative. That's going to be negative overall. Once we go to the right of negative 4, it's got to be positive. Once we go to the right of negative 1, it's going to be negative. To the right of 0, it's going to be positive. Then it's going to be negative between 2 and 3, and finally it will be positive. Okay, this one is going to have a turning point, and we'll have a look at that in a moment. We could differentiate, but I don't think we need to, and it's also really hard to solve, so unless you've got the calculator available, in which case you wouldn't need to do a lot of this anyway, because your calculator can do a lot of it. So let's have a look. So our asymptotes are at negative 1. So we've got x equals negative 1. And we've got an asymptote, the y-axis itself is an asymptote. Then we've got x equals 2. Okay, we've got our x-intercepts at negative 4 and at 3. Okay, the shape of this is going to be quite interesting. I'm going to start in the second section, this one. We know it has to be positive there. And we also know there's an asymptote over here and the intercept that is over here at negative 4. But what's going to happen as we go left from there? So if we look at the original expression, the bottom is a cubic. The top is a quadratic. X cubed will get bigger much more quickly than x squared. The other terms will become inconsequential if x is big enough, and you'll have x squared over x cubed, which is 1 over x. As x gets very, very big, that must head towards 0. So the x-axis is going to be a horizontal asymptote. Now the only way this can work is that that must come under there, have a minimum value, and then come back up towards the asymptote. This is sometimes a bit mind-blowing for students. We are crossing an asymptote, and there isn't a problem with that. You can cross a horizontal asymptote. An asymptote is a long-term thing. What happens when x is very large and negative or very large and positive? The wiggling about in the middle doesn't really matter. Now let's move over to the next section where this is negative. So between -1 and 0, we know that it's negative. But there's an asymptote either side. So what must happen is it must come up the asymptote, have a maximum point, and then go down. The same is true of the next section, where it's got to be positive. So that is going to look like that. Then in the final section, we've got the same sort of situation that we had over here. It's going to be negative up until the intercept at 3. So it must come in from the asymptote. And then the x-axis must be a horizontal asymptote. So it must take a maximum and then go back downwards towards the asymptote. If you graph it, you'll find that you have to zoom in quite a bit to see some of these things, like those in particular. And that's why sometimes a sketch is better than a graph, because you can really highlight the features. I doubt very much with this question that they would expect you to differentiate to find the coordinates of these points. Might expect you to find them if you've got a calculator, and indeed they're not nice points. They don't come out to nice values that's easy to find without a calculator.